Figure has unveiled Helix AI, a groundbreaking advancement in robotics that could revolutionize how humanoid robots interact with their environment. Unlike traditional robots that require extensive programming or repetitive training, Helix enables robots to instantly understand instructions, see their surroundings, and manipulate objects they've never encountered before. This could be one of the biggest breakthroughs in home robotics yet, pushing the field closer to true general-purpose artificial intelligence for physical tasks. Recently, Figure ended its collaboration with OpenAI, a move that surprised many in the industry. According to Brett Adcock, Figure's founder, the decision came after the company made a major in-house breakthrough in fully integrated AI for robotics, Helix. Shortly after announcing Helix, reports emerged that Figure was in discussions for a massive $1.5 billion funding around at a staggering $39.5 billion valuation. The excitement from investors suggests that they may have an early look at the technology, and if so, it's clear why this development is generating so much buzz. Helix integrates three core components: vision, language, and action into a single system. This means that rather than needing extensive pre-programmed instructions or specialized coding for each task, a Helix-powered robot can perceive its environment, understand spoken commands, and execute tasks intuitively. The implications of this are enormous, particularly for home robotics, which has traditionally been one of the hardest areas for AI to navigate due to the unpredictable and cluttered nature of real-world households. To showcase its capabilities, Figure released a demonstration video where two robots were given a simple verbal command. "Can you put away this bag of groceries?" The robots scanned the kitchen, identified appropriate storage locations, and cooperated to place in the items in the fridge and on the counter. In one particularly impressive moment, a robot placed an apple in a fruit bowl, demonstrating a level of contextual awareness rarely seen in AI-driven robots. Perhaps even more astonishing was the seamless teamwork between the robots, passing items back and forth without explicit micro-instructions, something that's notoriously difficult for robotic systems to execute fluidly. A key innovation within Helix is a dual system AI architecture, which balances reasoning and rapid physical execution. S2 or System 2. This is a slower, high-level reasoning component of Helix. It functions as a vision language model, interpreting verbal commands, analyzing the environment, and planning tasks accordingly. S1 or System 1. This is the fast motor control system that translates S2's plans into real-time physical actions, operating at an incredibly fast 200 Hz. Think of it as the nervous system of the robot responsible for executing fine motor skills without delays. This dual approach solves a long-standing problems in robotics, balancing intelligence and speed. Large AI models can understand complex instructions but are too slow for real-time movement, while fast motor control systems lack the reasoning ability to generalize across different tasks. By combining the strengths of both, Helix achieves a level of adaptability and responsiveness that previous robotic systems have struggled to reach. One of the biggest challenges in robotics has been object generalization, the ability to interact with new items without prior training. Traditional robots require thousands of examples before they can reliably pick up or manipulate a new object. Helix appears to sidestep this limitation, leveraging large language models and visual data to infer how objects should be handled. For example, if you tell a Helix-powered robot to pick up that weird plastic dinosaur, it won't need a pre-existing dataset of plastic dinosaurs to figure out how to grasp it. Instead, the AI will use its vision model to analyze the shape, estimate its weight and grip points, and execute the task as a human would. This level of flexibility is critical for home environments where objects vary significantly in shape, size, and placement. Helix introduces several major firsts in robotics, starting with full upper body control. Its system supports 35 degrees of freedom across the wrist, torso, head, and fingers, all operating at high speed. This is crucial for tasks like opening doors, grasping difficult objects, or even twisting its torso to look inside a fridge. Another groundbreaking capability is multi-robot collaboration. The demo video featured two humanoid robots seamlessly handling items to each other, interpreting shared tasks in real time. When given a command like pass the bag of cookies to the robot on your right, both robots processed the instruction, identified the cookies, coordinated the handoff, and executed the action without hesitation. This is a major milestone in robotics as collaborative robots are typically limited to highly controlled industrial settings rather than open-ended environments like homes. Unlike many AI robot systems that rely on separate neural networks for different tasks, Helix operates on a single neural model. This system consists of a $7 billion parameter vision language model or S2 responsible for perception and planning, an 80 million parameter transformer S1 dedicated to motor control. This unified approach makes Helix more efficient, reducing the need for constant retraining when faced with new tasks. Whether it's placing an apple in a fruit bowl or handling off a milk carton, Helix doesn't require fine-tuning for each specific action. It applies general principles to perform tasks naturally. Another major advantage of Helix is that it's designed for commercial readiness. The system runs on low-power embedded GPUs, meaning it doesn't need to be tethered to a powerful external server. This eliminates latency issues, improves security, and makes the robot fully mobile. Previous AI-powered robots have often been limited by dependence on cloud-based processing, leading to delays and reliability concerns. Helix's self-contained design ensures that it can function smoothly even in homes with inconsistent internet connections. Figure isn't the only company pushing forward in humanoid robotics. Meta is reportedly building an AI-powered robotics division, while startup named Apptronic recently raised $300 million with backing from Google DeepMind. Even Apple has been rumored to be exploring robotics, signaling that the field is becoming a major battleground for tech giants. Many humanoid robot companies have focused on industrial and logistics applications such as moving boxes in warehouses because these environments are more structured. However, Figure is betting on home robotics, which presents a far greater challenge due to the unpredictable nature of human households. If successful, Helix could set a new benchmark for general-purpose robots that can function across both home and industrial settings. While Helix represents a huge step forward, there are still unanswered questions. First, safety and security. Could a robot be hacked or manipulated? How will Figure ensure that Helix operates safely in homes? Affordability. Humanoid robots are currently expensive. Will mass production bring costs down enough to make them viable for everyday consumers? And lastly, reliability. The demo videos show smooth operation, but real-world performance will determine whether Helix can truly handle the unpredictability of human environments. Despite these uncertainties, the potential for Helix is enormous. With its ability to understand speech, reason through problems, and handle physical tasks in real time, Figure's AI could transform how robots integrate into daily life. From elder care to hospitality to household assistance, humanoid robots may soon be an everyday reality. Would you trust a humanoid robot to move around your home and assist with chores? Or do you think the technology still has a long way to go before becoming a household staple? As Helix continues to evolve, we may be closer than ever to a future where intelligent robots are as common as smartphones.